Welcome to this session on normalization in RDBMS. This is Kanimozhi, Assistant Professor, PG Department of Computer Science, Shri Krishnaswamy College for Women. In today's class, we will explore the concept of normalization, an important process in database design. Let's see the topic. Normalization and types of normalization. Let's see the definition of the normalization. So what is the process? What is the meaning of the normalization? Normalization is a data organization technique that is used in relational database management system. Main goal is to structure the data properly for reduce the redundancy or repetition of data is minimized. There are different types of normalization techniques in RDBMS. So let's see the normalization types. First normal form, second normal form, third normal form, BCNF, 4NF, 5NF. Each level removes a specific kind of problem or dependency in the data. In normalization, we will divide the large table into smaller tables and defining clear relationship between them. For example, rather than storing student and department details repeatedly in the same table, we separate them into different tables and link them using keys. This ensures data inconsistency, avoids anomalies, and allows for efficient storage and maintenance. So what is meant by data anomaly? It is the inconsistency for retrieving the data from the database is called data anomaly. Advantages of the normalization. Normalization provides several benefits. Eliminate redundancy, that is avoids storing the same data in multiple places. Second one, improves the data integrity, means ensures the accuracy and consistency of data. Third one, simplifies maintenance. Changes are made in one places and reflected everywhere. Fourth one, efficient querying. Queries become faster and more logical. Fifth one, avoids anomalies. That is, helps prevent insertion, deletion and updation anomalies. Sixth one, better database design. Overall structure becomes cleaner and easier to manage. Why normalization is needed? When data is not normalized, data anomalies occur. That is, inconsistency for retrieving the data will be occur. So we have several types of normalies. First one, insertion normally. Insertion normally means you cannot insert a record because some other data is missing. For example, you cannot add a new student without assigning them to a course. Second one, deletion anomaly. Deleting one record might remove other important information. For example, deleting a student could also delete their course details. Third one, update anomaly. Redundant data requires multiple updates leading to inconsistencies. Normalization helps avoid all these issues by structuring the data properly. Where the data normalization used in financial analysis, medical research, marketing, image and voice recognition, climate data analysis. Let's see the types of normalizations. Different types of normalization forms is there. 1NF, 2NF, 3NF, 4NF and 5NF. In 1NF, we will remove the eliminate the repeating groups. In 2NF, eliminate partial functional dependency. In 3NF, eliminate the transitive dependency. In 4NF, eliminate the multiple values dependency. In 5NF, we will eliminate joint dependency. Let's see the first normal form. First normal form. In first normal form, we will focus on eliminating the repeating groups in a table. Each cell should contain only one value and each record should be unique. For example, in left hand side right, we will see the unnormalized table. When we apply the 1NF, it will be considered like this. In unnormalized table, one particular student have multiple phone numbers. After removing the repeated values, it will be every record should be in a unique. Example, in first normal form, we will follow the following steps. First, remove the repeating groups. Second one, create a separate tables for each related data set. Third one, use a primary key to uniquely identify their example. For example, if one student has multiple phone numbers in a single field, we split them into separate rows, one for each number. This ensures that the table satisfy the 1NF. Second normal form. In second normal form, removes the partial dependencies. That means every non-key attribute must depend on the whole primary key, not part of it. To achieve 2NF, the table must first be in 1NF, remove attributes that depend only on part of the composite key. For instance, if the primary key is student ID, phone number, but student name depends only on student ID, we separate the data into two tables, one for student details, another for phone numbers. Next one, third normal form. Third normal form removes the transitive dependencies. A transitive dependency occurs when a non-key attribute depends on another key non-key attribute. For example, if a city depends on a region code and region code depends on the student ID, we create a new city table that maps city to region. Now, each table contains attributes that depends only on the primary key, ensuring greater consistency and independence. In next one, bias code normal form. Let's we called BCNF as 3.5NF. In BCNF is a stronger version of 3NF. It deals with cases where a determinant, that is an attribute that determines another, is not a candidate key. In BCNF, every determinant must be a candidate key. There should be no partial or transitive dependencies. This ensures that the tables are completely free from anomalies and fully normalized. At this stage, your database is efficient, reliable, and logically sound. Consider a table where the department depends on professor, not a course or student ID. If professor is not a candidate key, this violates BCNF. To fix it, we divide the table into three tables. One is professor department, second one is course professor, third one is student course. Now every determinant is a candidate key satisfying the BCNF rule. This results in a completely normalized database structure. We have seen how bias code normal form or BCNF removes most of the redundant dependencies in a database. However, sometimes even after achieving BCNF, there can still be multi-value dependencies, meaning a single attribute in a table may determine multiple independent values of another attribute. This situation causes unnecessary data repetition. To solve this, we use 4NF. A table is said to be 4NF if it is already in VCNF and has no multi-value dependencies, except here no multi-value dependencies except those that depend on a candidate key. In simple terms, 4NF ensures that every table stores only one type of relationship without mixing unrelated data. Let's look at an example. Here, suppose we have a table that stores each student courses and hobbies. Here, this table contains student ID, course and hobby. Same student have multiple courses and multiple hobbies. Here, both course and hobby depend on the same student, but they are independent of each other. This creates a lot of repeated combinations, 4 rows for a single student. To bring this table into 4NF, we separate these table into two separate tables. One is student course table, another one is student hobby. Student course table contains two columns, student ID and course name. Here, same student have multiple courses, that is DBMS and AI. Second table is student hobby. It contains student ID and hobby column. Here also same student have multiple hobbies, chess and music. Now each table represents a single relationship, one for courses and one for hobbies. This eliminates the multi-value dependency and redundancy. Here 4NF mainly removes the multi-valued dependency. Second one, it ensures each table represents one independent fact. It reduces repetition and improves database efficiency. Even after applying 4NF, sometimes redundancy can occur due to joint dependencies. This happens when data is reconstructed from smaller tables but produces extra or duplicate information. 5NF deals with such complex relationship. A table is said to be 5NF if it is already in 4NF and every joint dependency is implied by the candidate keys. In other words, a 5NF table can be decomposed and rejoined perfectly without losing or adding extra data. It ensures a lossless join and fully normalized structure. Example, let's consider a table that tracks which students are taking which courses under which instructors. Student ID, course ID, and instructor names. In this case, there are three independent entities. One is student, another one is course and instructor. If we update or delete any record, we might lose some important combinations or create duplication. To bring this 2 into 5NF, we decompose the table into small relations. One is student course table that contains student ID and course ID. Next one, student instructor table that contains course ID and instructor names. Another one is student instructor table. It contains student ID and instructor names. Now all three tables can be joined together to rebuild the original data but without any redundancy or anomalies. This ensures that the data is completely consistent and optimized. Here 5NF removes join dependency. Second one, it ensures lossless join between decomposed tables. The database becomes fully normalized and free of redundancy. Key takeaways about normalization. First one, from the normalization. Normalization is a step-by-step process used to organize the data efficiently in a relational database. It eliminates redundancy and ensures the data consistency. It divides large tables into smaller related tables, helping maintain data integrity and reducing anomalies. Data anomalies, we will saw the insertion, deletion, update anomalies. It occur when data is not properly normalized. And types of normalization. First normal form removes repeating groups and ensures atomic values in each field. Second normal form eliminates partial dependencies by ensuring all non-key attributes depends on the full primary key. Third normal form removes transitive dependencies, ensuring non-key attributes depends only on the key. BCNF strengthens 3NF by ensuring every determinant is a candidate key. 4NF eliminates multi-value dependencies, ensuring each table represents one independent fact. 5NF removes join dependencies, ensuring tables can be decomposed and rejoined without redundancy or data loss. When a database reaches 5NF, it is considered fully normalized, optimized for performance, consistency, and integrity. And then normalization removes us and focuses on these topics. Let us conclude. Normalization plays a vital role in database design. It helps us organize data logically, minimize redundancy, and ensure data integrity. A well-normalized database not only improves query performance and data accuracy, but also makes it easier to maintain and scale systems in real-world applications. Always remember, a good database design begins with a good normalization. Thank you for watching this normalization in DBMS. Thank you once again.